Yesterday we started talking about Unit 7, which is on exponential functions. And we talked about how an exponential function is something that is in the form y equals a times b to the x power. Now, you can have several different exponential functions. For all of them, a cannot be 0, and b has to be a positive number other than 1. B cannot be equal to 1. When a is positive and b is bigger than 1, we actually have a special type of function that's called an exponential growth function, and b is called your growth factor. So to be growth, a has to be greater than 0 or positive, and b has to be bigger than 1. If a is positive or greater than 0 and b is between 0 and 1, like a fraction value like 1/2, this is called an exponential decay function, and b would be considered your decay factor. Now, growth and decay are both very similar. If you look here, they both have this general shape. Growth is going up from left to right, decay is going down from left to right. And some of the things that we talked about yesterday in class, kind of summarized in both of these, is if your equation is in the form y equals b to the x, that would be when you have a value of a equals 1, okay? One thing you know is that you will have the points -1 and 1 over b, 0, 1, and 1 over b. And those will be on your graph. This is when a is equal to 1. In general, though, a rule you might want to follow is for any function that's in the form a times b to the x, at -1, your y-coordinate will be a over b. At 0, your coordinate is going to be a. And at 1, your y-coordinate is going to be a times b. And that'll be the rule that I use pretty much throughout this whole unit, okay? Again, if b is bigger than 1, it's an increasing function. If b is between 0 and 1, like a fraction, then b is going to be a decay function. Now it says the x-axis is a horizontal asymptote. What that means is that even though it looks like these graphs up here touch the x-axis, they really don't. They just get closer and closer and closer to it for an infinite amount of time. A horizontal asymptote, it's kind of like an invisible barrier, and this is where it's kind of cut in your graph, and the curve just kind of skims right along it, okay? Now, for any of these exponential functions, your domain is going to be from -infinity to positive infinity, which is another way to write all real numbers, okay? Your range, and again, this is just for b to the x when a is equal to 1, okay, is going to be positive, all right? And then down here, I've shown you some examples. These three right here would be increasing functions. Notice that your b value is greater than 1, and as your b value gets larger, the graph gets steeper. All of these would be decay functions because all of their b values are less than 1. So when you are looking at an equation like this, for example, our first one was y equals 3 to the x. This would be an example of when a is a 1. If you want to rewrite it like that so you can see the a value, that's perfectly fine. But all we really have to do is use the x-coordinates of -1, 0, and 1, and then use our pattern of a over b for -1, a for 0, and a times b for 1. We can get our y-coordinates to graph our points and then get a pretty good sketch. So at x equals -1, it's going to be a divided by v, which is 1 divided by 3, or 1/3. For 0, it's just your a value. For x equals 1, it's going to be a times b, or 3. And so when we plot these points, your graph will end up looking like this, and then you just kind of sketch it in. And again, the x-axis is your horizontal asymptote, so it just kind of skims along that. The second example we did yesterday, notice this one is -3. That means you really have the equation -1 times 3 to the x. All right? So using our pattern again for our 3 points, the y-coordinate for -1 is going to be a over b. The y-coordinate for 0 is going to be a. And the y-coordinate for 1 is going to be a times b. Well, when you graph these, what you'll notice is that now your graph looks like this. This would just be an exponential function. It would not be growth or decay because for either one of those, a has to be positive and our a is negative. So this would just be a general exponential function. We're going to skip the next 2 examples. If you go over to the next page, this is what we talked about in class today. This is how you can translate any general exponential function when it's in the form y equals a times b to the x minus h plus k. All right? Now, just to kind of remind you, x minus h and plus k, we have seen these before. We worked with them with absolute value functions. We also worked with them with quadratics. But these cause your graph to shift left, right, and up and down. Just to summarize, x minus h moves it to the right that many steps. X plus h moves it to the left that many steps. Plus k causes the graph to translate upward, and minus k moves the graph down that many steps. Okay. Now, when you have a function in this form, okay, what you're going to do first is you're going to get your starter points by just graphing this part of the equation, y equals a times b to the x. Then after you have those points, you'll plot them lightly on your graph, and then you will translate the graph using the rest of the equation. For example, in this example, I could rewrite this as y equals 1 times 3 to the x plus 1, and then plus 2. What I'm going to graph first is I'm just going to find my starter points for this part of the equation. So at negative 1 and 0 and 1. Okay. So at negative 1, it's going to be a divided by b, or 1/3. At 0, it's a, so 1. And at 1, it's a times b, or 3. Those are my starter points, so I'm going to plot those lightly on the graph. But I'm not going to connect them just yet. Now, the rest of the equation tells me to move this graph, or these points, to the left 1 and up 2. And so I'm just going to move to the left 1 and up 2 for these 3 points. And these will be the ones that I connect. Now, one thing to notice is your horizontal asymptote is no longer the x-axis. That invisible barrier, that asymptote, moves up with the graph. So that invisible barrier, or that asymptote, is now at y equals 2. That affects your range. Our domain will still be all real numbers, but now your range, because the graph moved up, is only values greater than y equals 2. Let's look at this last example. Again, I'm first only going to graph a times b to the x, and then I will translate with the rest of it. So at negative 1, my y-coordinate is going to be a divided by b, or 1/2. At 0, it's going to be my a coordinate, or my a value, and at 1, it's going to be a times b, or 8. So I will plot these points first. I'm not going to connect them because now I need to translate. X plus 2 tells me to move it to the left 2, and the plus 1 at the end has me move the graph up 1. So I'm going to move each of these points to the left 2 and up 1. And this is now your curve.